We've now added all we need to start preparing our model for a successful analysis. So, next we'll add some loads to our model. Specifically, let's add some super dead and live loads. For this, we'll first make some changes to our user form code so that it prepares our worksheet correctly, as we did various times previously. We'll add a place for both our load types and adjust cell borders and column width. And let's just launch our form to prepare our worksheet as usual. Alright, let's create a new function to add loads to our model. We'll call our function addLoads, and it will receive the super dead and live load values as a value of kilonewtons per meter squared. Remember to try and keep your variable names concise but also readable. For example, here, instead of writing super dead in full, we'll write just SD to abbreviate while maintaining readability. You can also increase readability by commenting your code quite explicitly, though we've already touched on the pros and cons of this approach. Now, this function will be quite simple. We'll start by adding a new load pattern. To look for the function we need, let's have a look at the SAP 2000 API since it's been a while, and it's always a good idea to keep it in hand. The function we need is in Functions, Definitions, and Load Patterns, and it's simply the add function. We can see that the add function takes a name and a type of load pattern that can be any one of these values. It also takes a self-weight multiplier and a flag to add a corresponding linear static load case. We'll call this function 2 times. The first time we'll create a new super dead load pattern with the corresponding enumeration type. Remember that we can also use the numeric value instead of the enumeration value, which, in this case, is 2. Then, we'll add the live with the corresponding enumeration value, alternatively, simply a 3. In both cases, we'll set the self-weight multiplier to 0, though, we could leave this blank, and it will automatically assume it is supposed to be a 0 as that is the default value. We'll also tell SAP 2000 that we want to create a corresponding load case. Next, we'll use the select object to automatically select all objects in our slab group. And we'll use the setLoadUniform function of our area object to add our load as uniform values to all our floor slabs all at once. Let's quickly look at the setLoadsUniform function. We can ignore the first name parameter as we'll see. We only really have to look at the loadpat, value, dir, and the item type parameters. Let's call the setLoadUniform for the super, dead, and live, with their respective values. Both will have 10 as the value of the direction parameter as that is the direction of gravity using the global coordinate system. And both will also apply to the selected objects. To finish our function, let's just clear our selection to be sure it doesn't impact anything else. So, just to expedite things a bit, and since we won't be making much complicated code, let's also add 2 more functions. The first one, we'll call editMassSource and it won't need any inputs. We'll declare 2 arrays, a string array for load pattern names and another array of doubles for the load pattern multipliers of our mass source. Now, we'll resize both arrays and fill them with our super dead and live load patterns. We'll also assign a multiplier of 1 and 0.3, respectively. Now, let's call the set mass source found in functions, definitions, and mass source. We'll edit the existing default mass source called MSSSRC1. We'll set all the flags to true, we'll give it 2 as the number of loads, and we'll provide it both our arrays. Okay, almost done. Let's just add a new function to edit the modal case and we'll be all set. Let's call our last function edit modal case and we'll give it the number of stories. And it's going to be a very simple function. All we need is a return variable and the function to edit our modal case's number of modes. We can find this function under Functions, Definitions, Load Cases, and Modal Eigen. It's not a complex function. Let's just give it the modal name for the existing modal eigen case. Then, we'll use the VBA max worksheet function to choose the maximum number of cases between either 12, which is standard in many instances, and 3 times the story number. This is so we allow SAP 2000 to calculate more modes if a building is tall enough, which can be interesting or important for the modal analysis of taller buildings. We'll just set the minimum number of modes to 1 and we're all set. Let's just call our functions from the main application function. And we can now test it out, though we won't really see any visual changes to our model, as expected. Okay, let's just check that everything was added correctly. First, we'll check the loads by clicking on any slab to examine it. There we have both our super dead and live loads. Next, let's check the mass source. Everything seems okay. We have our mass source with both our load patterns and their respective multipliers. Finally, let's just check that the modal eigen case has the correct number of max modes. This building has 6 stories, so we should see 15, which is 3 times 6 minus 1 basement floor. There we have it. We have now added loads, edited mass sources, and the maximum number of modes. Next, we'll be adding a custom response spectrum function and the load combos as well.